I work on one aspect of Down syndrome related to later in life, which is Alzheimer's disease. And I will talk about ways to potentially prevent or actually make the process easier in Alzheimer's disease, in Down syndrome. Den här bilden visar att de här ljusblå här är Down syndrom. Det här är generella populationen och visar incidens of Alzheimer. So what you can see here is that Alzheimer's disease in people with Down syndrome is higher and happens at an earlier age than in the general population. We don't know why this is, and so we're studying this together with groups of people across many different countries now and try to find this out. What are the risk factors, riskfaktorer för Alzheimer i Down syndrome? The biggest risk factor is age, actually, just like in the general population who has Alzheimer's disease. But there are also many conditions that we might see in Down syndrome that could possibly be interpreted as dementia, but may not be dementia. Hearing loss, for example, and low thyroid function. Also vision loss, pain, sleep apnea. Sleep apnea is actually has been studied quite a bit in Down syndrome, and almost up to 50% of persons with Down syndrome might have sleep apnea. And if you cannot sleep, you cannot think. And so that's a problem that we should fix, by, for example, using CPAP and other technique. So because of these different comorbidities, it's very difficult to diagnose Alzheimer's disease in Down syndrome. And research groups are working together, for example, in Barcelona, in Paris, at Harvard University, and Irvine, University of California, Irvine, are working together to find one set of testing that could diagnose dementia in Down syndrome. So, memory problems in Down syndrome. What we know during development is that people with Down syndrome have very strong understanding of social interaction and are quite lovely people and have really no deficits in understanding social interaction but have a weakness in motor development, for example, speech and language and hearing loss in many cases. Visual memory skills are better than auditory, maybe because of problem with hearing. And so what's been interesting is that there are clinical studies on people of all ages with Down syndrome in terms of training. So one study showed that if you trained people with Down syndrome 3 times per week for 8 weeks, and this was the people participating were children, teenagers or adults, so all ages, was actually very beneficial, something called cognitive training. And what we mean by that is that they were trained with visual, so they were shown images, and they were trained with verbal presentation. They were trained on remembering certain words, sentences and so forth. And in all people with all different ages, you can see that their memory was much better. This is the group that received the training, the black bars. Training was better and stayed better for at least 3 weeks after the testing period. And this is only 8 weeks of training. So we already know that of all ages, people with Down syndrome can benefit from training. So my specialty is working with biomarkörer. We can do this either before somebody has died or after they died by looking after people died, looking in their brain and studying why people with Down syndrome have Alzheimer. And is the Alzheimer similar to Alzheimer in the general population, or are there some specialties, and how can we recognize that? So the biomarkers that people are using are, for example, MRI or PET imaging, biomarkers in blood or CSF, which means likvor, where you have to actually do a spinal tap and get some fluid. But we have started working in a big group of people, including the group in Barcelona, for example, and also at Harvard and Irvine, on something called Exosomes. And so exosomes are tiny little vesicles or bubbles that every cell in the brain is releasing. And inside that little bubble are proteins that the cell is trying to get rid of. And so I will show you some data on this soon that shows that those little bubbles contain amyloid and phospho-tau, which are two proteins very common in Alzheimer's disease. So we and others have started looking at these exosomes that you can actually obtain from a simple blood sample. And they're like a small message from the brain. So what you also can do that I mentioned before is studying brain tissue post-mortem. And it should be said that actually Alzheimer's disease can only be diagnosed after death as we stand today. And so I'm the director for a brain bank in Charleston. And we have about 126 brains that we're studying now. And I talk a lot to people about donating brain tissue because it's extremely important. That's the only way we can find out what's going on in the brain. And I would say about 20% of the brains that we receive that had a clinical diagnosis of Alzheimer's disease actually have something else. And we find that out by looking at the tissue in the brain. So it's extremely important. And I know here at the Karolinska there is a very large brain bank that is involved in Department of Pathology. And I would urge everyone, I'm a brain donor, so I would urge everyone to actually donate your brain. You won't need it after death. And so research needs it to find out what's going on. And this is especially important actually in Down syndrome, because there are very few brain banks that have specialized on Down syndrome. And there's one at Irvine, for example. There's one at University of Maryland. There are a couple of them in Europe also. But it's very few that have specialized, so there's very little that we know about the brain in Down syndrome. And so it's very important. So when we look at the brain, what do you see? I don't know if it's, can you see it clearly? Good. So what people do after receiving a brain, and so this is two brains. One is from a control that was 63 years old, the one on the left here. And the other one on the right is from somebody who had Down syndrome plus Alzheimer's disease, who was 61 years of age. And so what you see here are, on the right side in the Down syndrome brain, you see a lot of black clumps. And these are called plaques, plaque in Swedish. And then if you look closely, you would also see what I show you here. These are nerve cells, these beautiful little things here. Here's a plaque. And the nerve cell actually has accumulations inside of toxic material. That's called a tangle. Fibriller in Swedish. So we have plaque och fibriller that are actually gathering in the brain. And we don't know why this is, and there's actually some clinical studies now going on trying to determine, can we get rid of these? You know, is there a way where we can actually get rid of these in the brain? We know, for example, that actually the plaques or the amyloid in plaques can, for example, be released with a vaccine against amyloid. And there's actually a study going on in people with Down syndrome right now on this amyloid vaccine you might have read about in the paper. It looks very similar to Alzheimer's pathology, and the only thing is that it's much earlier in life. So you can actually see people that have clinical symptoms of Alzheimer's in their 30s sometimes. So what's the next biomarker? You can use imaging, and there's an excellent group here at the Karolinska, Agneta Nordberg, and she has done PET imaging, and what PET means, positron emission tomography, where you actually inject a substance into the bloodstream and then you look in the brain. And Agneta Nordberg is working on a project and is very interested in actually studying people with Down syndrome before they can have Alzheimer's disease to see when it happens and what we can do. But so this group here, Gary Small and collaborators in California, did a study with a PET ligand or marker called FDDNP. And what he was able to show here is actually that, here's a control. The darker blue is normal, and then red and yellow is when you have accumulation of the amyloid. So what you can see in the brain of somebody with Down syndrome, it's already, that's a 33, there's a yellow up here in this frontal cortex, which is in the front here of the brain. This is the part of the brain involved in something called executive function or decision making, exekutiv funktion. And so what we think is that Alzheimer might start in this part of the brain in Down syndrome and might develop a little bit differently than it does in Alzheimer in the general population. And knowing that is very important because then we can look for different treatments that we can do. And then by the time this person is 59, it's widespread yellow and red throughout the brain, similar to what you would see in somebody with Alzheimer's disease here. So this is one way while somebody is still alive and functioning can go and have the scan done, and the scanning, it's top notch what's being done here at the Karolinska in Agneta Nordberg's group. So if you're interested in that, it's definitely something, there's studies that are ongoing. So we're also doing some kind of imaging on tissue that is post-mortem or brain tissue from individuals with Down syndrome. And so this is called molecular imaging. And what you can see here is different groups of substances, for example, proteins or fatty acids and things like that. And in this case, we looked at fats. And so here are two sections from a control brain. And here are two sections from somebody with Down syndrome. And their changes in the fat, the composition of the fats in the brain might show sort of something that happens early in Down syndrome. So now we're focusing in on this group of fats to see maybe, for example, the composition of diets, omega-3s, those kind of things could help. So it's just ways to look at large groups of fats or proteins or enzymes and those kind of things. So let's go back to these little exosomes. They are like a little message from the brain, little tiny bubbles, and they are secreted, and we don't know really why, but in the blood, most exosomes actually come from the brain. And so what you do is that you get the blood sample, and then you do a chemical process so you can purify. So now you have all your exosomes and not the other blood part. And then you can purify so you have only the exosomes from brain. And so this was a guy named Ed Götzel, who works at National Institute of Health, came up with this process in 2014, and it's quite interesting because what he's been able to show actually is that these exosomes contain the toxic thing amyloid 10 to 15 years before someone shows any symptoms of dementia. And so maybe it will be part of a normal blood panel. So imagine that 10 to 15 years before you see any dementia in a person, amyloid shows up. This tells us that amyloid, the cells in the brain are desperately trying to get rid of all the amyloid, but it's not successful for some reason. And so if we can then figure out at that stage, we should start intervention, we should start prevention, and that would be the goal. So we are doing a study right now with for example, Juan Fortea, who's in Barcelona, and together with Ira Lott, who's at Irvine. And we received a large number of blood samples from people with Down syndrome. And the people were anywhere from age 8 years of age to over 65. And then we purified the exosomes and looked for amyloid. And we also looked for phospho-tau, which is the protein in the tangles, fibrillina. So we looked at these two proteins. And we divided them below 35 and over 35. And what you then saw is that the controls have very low levels of amyloid, called A-beta 1 to 42, very toxic form of amyloid. But the people with Down syndrome already that are below 35 have higher levels. And then when they're over 35, much higher levels. And the same thing is true also here for the phospho-tau, higher levels. So if you look at this in terms of just age and look at all the samples, the black dots here will be are the people with Down syndrome. The white dots are those from controls without Down syndrome of all different ages. And what you then see here is that amyloid does seem to go up with age. Here's from 8 years of age up through 65 or 55 here. And you can see amyloid is steadily increasing. But already in young age, you have double the amount. And why is that? Well, it's simply because amyloid, the gene for amyloid, is on chromosome 21. And so people are born with higher levels of what's called the amyloid precursor protein, APP. So that's not so strange. We would expect to see that. But stranger yet is actually the phospho-tau levels, which are very high in some people, even when they're very young. And so now we're trying to see, why is that? That's interesting. Why are the tau levels so high? And are there ways where we can actually do, there's now some specific tau PET that could be done. So we could look in the brain of individuals and see, where is that tau located? Is it damaging? Is it accumulating? But it gives us something, you know, so this means we need to start early and look as people are teenagers maybe, and start looking for the tau. Maybe that's when we need to do prevention. So just to summarize these biomarker studies, the data show us we should start prevention early. And what we know, for example, in Alzheimer, in the general population, walking, perfect example. There was a French study that showed that people that walked 30 minutes 3 times a week lowered the Alzheimer risk with 50%. Everyone walks. Who walks? Raise your hand. Do you walk? Yes. Everybody walks, and everyone also with Down syndrome should be walking. Everybody should walk, because it's a very simple thing, you know, get the dog and start walking the dog. A very simple message. We also have data, and I will show you some of these data also in mouse models that suggest maybe vitamin E, and we'll hear also about green tea. And there's a study at the Karolinska on omega-3. So all of these supplements, maybe. I'm a proponent of blueberries. Anyone eat blueberries? Every day, right? Cancer prevention, eye, vision prevention, and also Alzheimer prevention. And so all of these things together are very important. Those of you that have children or other relatives with Down syndrome, blueberries, everyone likes blueberries. The Swedish blueberries are better than any other blueberry, actually. It's true. They are 20 times higher in their antioxidant value, the Swedish blueberries. You see how your tongue gets blue? That's the good stuff. So don't eat blueberries if your tongue is not getting blue. So all of these things are important. They need to be started early, in childhood, in teenagers. And then we also want to see, you know, our study was only 8 years old and older. We would like to start and looking at people old, even younger than that, to see when is amyloid elevated and when is phospho-tau elevated. And so these studies will be expanded. So a couple of slides, a couple of studies that we've done in mice. I like to go back and forth between mice and men and women. And so mice are very good, especially for Down syndrome research, because there are good mouse models. It allows us to study which genes are involved. And so we can, for example, do a knockout mouse, where we take one gene out and keep all the rest. So it's a very good way. And we can validate new drugs, make sure that they're safe, make sure they do what they're supposed to do. And we can do very longitudinal studies also with mice. They only live for 2 years, so that's perfect actually. It's within a grant period. So these are the mice that most people use. There are new mouse models now. TS65DN mouse, it's this guy here. And they have about 100 genes common to humans that have Down syndrome. So it's a fairly good mouse model. There are better ones that we will continue to study. And these mice are interesting because they have, if you train them and have good training going on. They're perfectly fine until they're about 6 months of age, which is almost sort of a 30-something in humans. Then they start having some memory problems. And how do you test that in mice? You have to have them run or swim in this kind of maze, and then they have to find a platform. Especially if they're swimming, they find a platform, and then you count how many errors they make. So it's actually fairly similar to what exists for human testing. There's actually a colleague of mine in Arizona who has a human maze for children, and in the end of each of the arms is a candy. So we shouldn't teach your kids to eat candy, but they do very well with the candy. And so what we saw there is that at 4 months of age, this is how many errors they're making here. At 4 months of age, they're completely normal, no memory loss. And then when they are 10 months of age, they actually have higher memory than any other group, this light gray here. So it's a good model to test different drugs. So what we tested, among other things, for example, I should also say that in the brain they have a loss of certain nerve fibers and nerve cells. This is in the hippocampus, a big part of the brain responsible for memory. And so you can actually measure how many cells are lost, and then you can use it as a good measure. And we tested vitamin E because there was a study done by Mary Sano in New York on vitamin E in people with Down syndrome. The study was not very effective, but I think they started too late in life. And so here we started early, and we actually found that the vitamin E trisomic mice, or Down syndrome mice, had completely the same memory as controls. So it was really preventing memory loss. And nerve cells were also completely prevented the loss of nerve cells. And so vitamin E was very powerful in this model. So now I think there are more ongoing studies with vitamin E in combination with other things in clinical. It cannot hurt. Everyone should eat vitamin E actually as a prevention. Not huge doses, but moderate doses of vitamin E. So another little study, I just show this because they're beautiful pictures, I think. We're doing in the mice, we're looking specifically for a part of the brain called the locus ceruleus. This is the part of the brain involved in executive function and decision making. And so what we're doing is using a very novel technique called a designer receptor. You can actually, the abbreviation is DREAD. If you look up DREAD on Google, it comes hairstyle, all of this, but we're using a different DREAD. It's these designer receptors, and if you put those in the nerve cell, you can actually control the nerve cell and make it fire or not fire, on and off. And by doing so, we have actually found that this particular nerve cell here, it's actually in the brain stem of the animal right here, actually seems to control two things. One is hyperactivity. Hyperactivity is a very big problem in Down syndrome, because if you're hyperactive, you're less able to learn and you're not paying attention. And so when we control these cells and make them better, more boisterous, we actually can prevent hyperactivity and improve memory. So this is all connected. So this is something that we're using that will not be used in humans, but it allows us to see which nerve cells are responsible, and then we can actually design drugs specifically for these nerve cells. So there's a drug used for people with ADHD called atomoxetine, and atomoxetine can be useful in Down syndrome too, I think, because it prevents hyperactivity, increases attention. So what about exercise and prevention? There are some studies that suggest that people with Down syndrome might have trouble exercising because of motor skills and coordination, but I think there's always something that you can do. You can swim, you can play soccer, you can ski. We actually have a person in South Carolina, Katie Smith, and South Carolina is not known for its skiing. We're on the beach. But Katie actually won in the last Special Olympics, won 2 medals. And she's so extremely proud of this. So she's a skier. There's always something for every individual that they can do. So they're doing a study now, Arizona State University, to see if exercise itself, it could be treadmill, it could be walking, it could be swimming, is going to be beneficial for memory function. And my intuition tells me absolutely this is the case. So we are doing a study actually together with from Kamprad, funded by Ingvar Kamprad here, on older adults, where people are using We Active or yoga or memory training. And exercise so far using the We Active is most beneficial. And I think you can get almost anyone to use the We Active. Everybody know what this is? So this is a PlayStation game. And so if you have teenagers probably play that all the time. It's a PlayStation game. It could be, well, we would like to work with Sony, for example, to get this installed at if people live in group homes and so forth, they can actually compete with each other. And there are games for this We Active, there are games for dancing, bowling, ping pong, all these different things. And we actually found extremely beneficial effects of the We Active on memory function. And this is something we now like to extend to also people with Down syndrome. I know there will be good effects, actually. There will be very beneficial effects. We also like to partner with Special Olympics to see how, for example, playing football and other sports can protect against Alzheimer's disease, and we certainly think that's the case. So we have, just to summarize, I will tell you a little bit about the organizations that exist now that are specifically for Alzheimer in people with Down syndrome. And so we started a professional interest area. There's a huge Alzheimer organization across the whole world called iStart. And iStart have special interest groups, and our group on Down syndrome, actually we're both, you're a member of this, right? There's actually 38 countries involved and more than 250 delegates now in this special interest group. So there is a huge interest in Down syndrome related Alzheimer, and the interest will be, how are people with Down syndrome so predisposed for Alzheimer, and what can we do, and what can we do to prevent, and are there medications? There are actually some medications used in people with Alzheimer in the general population that are not very useful for those with Down syndrome. So we're trying to actually translate and figure out better medications, better prevention measures. There's a lot of exercise studies done in people with Alzheimer in the general population. Nothing really has been done so far, not much in Down syndrome. So what we're hoping is to engage companies. We have engaged the National Institute of Health already. They just funded 2 clinical centers, and we hope to, and Alzheimer's Association are extremely supportive and very interested. And so what we also hope to do is actually have the Down syndrome associations in different countries start working with the Alzheimer's Association. Because Alzheimer's Association often have a lot of money. They are very tied to political movement, and they have their own lobbyists. And so we hope to actually ride on that ride with them, you know, and make sure that money and effort is put into this. And I know President Obama had a new national plan for Alzheimer, and in it he talks about Alzheimer in people with intellectual disabilities. But a lot of it is just talk right now. And so we are nagging and making sure that this is heard in Washington and that this is something that's important. People with Down syndrome live, when I was in graduate school, lived to their 20s. Now they live to their 60s. So why should this population not have the same effort, the same support? So our group of people are spread all over Europe, and you can see Karolinska, Barcelona, and all over the United States. And we think that if we can raise awareness for brain donation, blood donation, there's also a registry that the National Institute of Health has started called the Down Syndrome Registry. And I've been told that it will be translated, for example, the Spanish translation is on its way, and that all the countries in Europe will be participating in the registry. because through the registry, you as a family can hear about what's going on, and you can hear about clinical trials, and you'll be able to participate. So there was a lot of people who did these data. Here's the group, and we are participating both in the Alzheimer walk and in the body walk every year. And I think that's very, very important. Thank you very much.